Thank you for joining me for the third episode of the Doc Talk with Liz podcast. Our guest today is Dr. Allison Fitzgerald. Dr. Fitzgerald is currently an MD PhD student at Georgetown University who studies Immuno Oncology. Hello, everybody. Today I am speaking with Dr. Allison Fitzgerald, who is an MD PhD student at Georgetown University studying Immuno Oncology. So thank you so much for joining us, Dr. Fitzgerald.
Absolutely. Thank you for having me. It's an honor and a privilege to be here.
Awesome. Thank you so much. So can you just kind of start off by telling us what your journey is into science, what got you interested, and then different research that you did that encouraged you to go into immuno-oncology?
Yeah, absolutely. And I think you'll find it's pretty common that most trajectories are never the same for anybody, and there's a lot of back and forth. And even still, I think people are surprised to hear that at this point in my career, I still don't fully know what my future will hold. But I always had an interest in cancer research. And I think like a lot of people, there's been a lot of people in my family who have had cancer, and there's a lot of different ways to respond to that. And so my response was essentially to try to learn as much as I could about it. That was like kind of my coping mechanism, and it sort of ended me up here. But I went to high school, and then afterwards I attended a small liberal arts college called Colorado College in Colorado Springs. And the reason I went there is because they actually have an alternative education system where you only take one class at a time for 3.5 weeks. And then you have like what's called a block break in between your blocks of classes where you get a couple days off. And I actually thought that was a pretty good approach for me because I was a huge procrastinator before going to college. And then in college, I majored in biochemistry, and my first biochemistry teacher really encouraged me to do research. So she had a lab, and it's not a big institution, so like Ohio State. So the research isn't quite as like, I guess, high level. But she did have a lab, as a small lab, and you got to work directly with her on your own research projects. And I really enjoyed the creativity which I think a lot of people don't think of science as being creative, but I actually would consider it much more creative than medicine at this point. And then, so I started doing research there. I did research throughout undergrad. I guess I started my sophomore year during the summers. I actually ended up staying a little bit after I graduated to finish my research project. And then, of course, I was looking for what to do next. I thought I wanted to go to med school, but I hadn't taken the MCAT and I needed to make money. So I applied for research jobs all over the place. And I was fortunate enough to get a research position at Dana-Farber Cancer Institute, which is Harvard's cancer center. And I, again, lucked out, and I had a really great mentor there. And I studied basically liquid biopsies, which is a way to look at what tumors and cancers are like at a molecular level using a patient's blood so that you don't have to go in and do invasive biopsies. And I ended up doing that for 3 years, which is kind of a long time to take off between undergrad and med school, but I didn't regret it one bit. I got a lot of research experience there on like how to actually work in a lab. And so that was great. And then from there, I applied and fortunately got into Georgetown's MD PhD program. And then this is way, way in the future for you, but if anybody does want to do a PhD, advice that I always got is it's more important to pick a mentor that you like than the research subject. And fortunately, I liked both my mentor and my research subject. But I think at that point, the general logic is that you do your PhD with a mentor who can support you in the way that you need to be supported. And then there's a concept called a postdoc, which a lot of people aren't familiar with, but it's like extra training after your PhD. And at that point, you can really specialize in the field that you want to specialize in. So that's kind of the advice I got. And I just finished my PhD in January. Here I am.
Awesome. Thank you so much for sharing that. And could you kind of give us a little bit of an idea of your current research, like with Immuno Oncology, what specifically you study in that field, that kind of thing?
Yeah, absolutely. And I want to real quick give like a brief overview of MD PhD programs because
That'd be great.
yeah, they're not like, I didn't know all about them before. I just knew I liked research and medicine. So I was like, oh, I guess I'll do this, which probably wasn't the best first. But so MD PhD programs is like a broad category, and it's meant where you get trained in medicine, obviously, to be a practicing physician, but also you get your PhD. It's usually about 8 years. It can be between 7 years and I guess 9 or 10. And the general structure is to do 2 years of med school, which are considered your preclinical years, where you take all your coursework to learn basic medicine. And then you pause after you take your first board exam, and then you start your PhD. And then you finish your PhD, and then you go back and you finish your last 2 years of med school, which are the like clinical part of med school, where you start rotating and getting in the hospital and actually seeing patients. When I say rotating, that's the term for when you go into the hospital and you see different specialties. So like every 2 weeks-ish, you change specialties, and that's termed like clinical rotations. And that happens the last 2 years. So your PhD is actually shortened. Most PhDs in the US take between 4 and 6 years. And you do usually 2 years of coursework at the beginning of your PhD. But for MD PhD programs, most programs, and this will vary program to program, but they cut the amount of PhD classes you need because those medical school classes count towards the PhD classes. So since I took biochemistry in medical school, I didn't have to retake biochemistry in graduate school. So that cut my 2 years of classes down to 1. And so that's kind of how they shorten the whole process for you. And then MD PhDs are like the broad category, but there's another subset called Mstps, and those are medical scientist training programs. And that's funded by the NIH. The NIH funds these programs, and they're completely free and you get paid to do them. So you don't have to pay to go to med school or grad school, and usually you get a stipend of about $30,000 a year throughout the whole time. So it's a really nice program, and a lot of people, I mean, although I will say doing an MD PhD is not a good way to avoid medical student loans, because you end up not getting paid for 4 years when your colleagues who went straight through with medicine end up making a lot more than you. But it relieves the pressure of being in school for so long. So that's a bit about MD PhD programs, because there's not a ton of information about them all over the place. Maybe there's more now, but anyway, okay, so about my research specifically, Immuno Oncology. So I would assume most people are familiar with the concept that cancers are basically a cluster of cells. So humans are made up of tons of cells, and they naturally have programs to keep them from dividing too much. But cancers happen when a cell, something about that program gets messed up, and they keep dividing continuously over and over and over again. And you end up getting this mass or tumor of all these cells. But the problem is it's not just a homogeneous mass. They often recruit cells in their environment. So cell types like fibroblasts or even immune cells to help them grow. And it actually wasn't until relatively recently that the immune system was thought to even be involved in cancer. For a long time, people thought that cancer was just like immune and not an immunological way, but a more metaphorical way, in that it wasn't impacted by the immune system at all. And so only recently people started to appreciate how involved the immune system really is. And there's pro-tumor immune cells and anti-tumor immune cells, and it's basically a battle between the two to try to regulate tumor growth. And obviously the tumor wants the anti or the pro-tumor immune cells to come in, and then your body, because you want to live, has the anti-tumor immune cells, and it's all very, very complicated. So it's really a very, very blossoming field right now, and it's an exciting field to be in this moment, because there's so much research and so much advancement happening, honestly, every week, and so much exciting new technologies coming out. So I'm fortunate in that the PI that I liked happen to study cancer immunology and immunotherapy. But yeah, that's like a very brief idea.
Awesome. And then would you have any tips for people who may want to go into immuno-oncology, like different research you would suggest they do, or like volunteering, just different things like that, maybe too?
Yeah, I think honestly, this is going to sound odd and probably overwhelming at the stage that people might be thinking of starting to do this. But if it's before you're in a PhD program and you want to get exposure to different things, say you want to take a gap year and you're interested in immuno-oncology, there's a couple ways you can do it. First is to apply for like technician jobs, which is what I had. And I think that is a great way because you actually get paid, which is important, I think, for a lot of people. There's probably a handful of like, if you're an undergrad or in high school, there's probably a lot of research programs to like encourage participation in research, but often those are kind of short. They're usually like 3 months. And you can get exposure that way, but it's hard to like really start to understand the concepts in that short of a time. But if you can do something long-term, like at your university, if you're an undergrad, or if you're in high school and you live near a university, you can maybe find someone to work with. And honestly, the best way to find someone to work with is to just email them directly. And I know that that probably sounds wild, but if you just search like immuno-oncology on the internet and websites like Science and Nature, they have like news sections where they'll interpret research for people who aren't experts in the field. And you can read that, and if anything sounds interesting to you, you can look up who actually did the research and where they are. And you could email them and see if they're open to having a high school or undergrad volunteer. Of course, those positions probably won't be paid, so that makes it more complicated. But maybe there'll be some resources to support you if you can get into a program or something like that. So I know it's kind of scary to like cold email people, but honestly, sometimes to find like research mentors, that's the best way to do it. Or if there's someone at your college who might know someone, you can always talk to your college professors and ask them, I'm interested in this. Would you happen to know anyone? Because most college professors in sciences have PhDs, so they probably have friends who went into more research positions or are doing research themselves.
Okay, thank you. To recap, in the first part of this podcast, Dr. Fitzgerald shared some tips for going into immuno-oncology. She also shared that Science and Nature have sections that interpret research for the public, and that this is a good resource for finding researchers and emailing them to ask to do research with them. She shared that liquid biopsies are a less invasive way to look at what tumors and cancers are like at a molecular level using the patient's blood. She also mentioned that when deciding to do a PhD, it's more important to choose a mentor you like than a research subject. She's mentioned that MD PhD programs are between 7 to 10 years and allow you to get a PhD to do scientific research while also getting an MD to practice medicine. Lastly, she mentioned that our cells naturally have programs to prevent excessive division. Cancer occurs when the program malfunctions and division is not controlled. And then could you just kind of explain a concept that you find interesting and think that other people might find interesting in immuno-oncology, maybe something that people might not typically know, kind of just something interesting?
Yeah, absolutely. So I think I was recently exposed to this concept that was so cool. But so I mentioned already, there's anti-cancer immune cells. So basically there's two types. There's a cell type called natural killer cells, and there's a cell type called T cells. And those two cell types naturally in your body can usually recognize and kill cancer cells. But when cancer develops, something goes wrong. And for whatever reason, those T cells are no longer able to recognize and clear the cancer cells. And so recently, people have been engineering the T cells in labs and basically using fancy scientific techniques like using viruses to like inject certain DNA to make certain proteins and stuff. And you can get these, they're called CAR T cells, so chimeric antigen receptors. and they engineer these T cells to recognize specific proteins that they know are overexpressed on the cancer cells. So proteins that are really high levels. So then these T cells are like, have you ever seen Iron Man?
Yes.
You know, like the robot Iron Mans that they come out with in the later ones. These T cells are like the robot Iron Mans that are like super jacked up, you know, and they can go in and recognize the tumor. They've actually cured some patients now with this therapy. But recently I saw work that's actually done at Dana-Farber where they don't just do that, but they take these CAR T cells and then they engineer them to secrete immunotherapy when they become activated. So when they get to the tumor cell, they actually already in the tumor environment, they start secreting anti-cancer drugs into the tumor to start not only kill the cancer cells themselves, but also use drugs to regulate the cancer cell, which is like just absolutely insane to me. That like concept that and that advanced engineering is just so impressive.
Yes, awesome. That is definitely very interesting. And then additionally, like with your research, even though you said that you just recently graduated with your PhD, correct?
Yes.
Okay, so kind of can you give us kind of a glimpse into the life of an MD PhD student, even though I know that every day is different than the last? Like, are there like some core things that you kind of do that are typical?
Sure. I think, yeah, the day-to-day of an MD PhD, and this is such a great question, the day-to-day of anyone is always like so abstract if it's not you, right? Like, what are you doing all day long?
Yes.
It depends a lot on what part of the program you're in. And so I think it's easier to conceptualize what medical school is like. You know, the first years of med school, it's basically like being in college. You wake up, you go to class, you study, and then you take tests. Right? So it's like pretty similar. And it's very structured. But the PhD part is very, very variable. So it'll depend a lot on what lab you pick, what specialty you pick. If you can do pretty much whatever you want, which is pretty awesome. So you can, you know, if you want to do research with patients, you can find a lab that interacts with patients regularly. If you want to do computational research and really like learn how to use big data sets and analyze those, you can do that as well. And obviously that would look different because the person who's analyzing big data sets would be at their computer most of the day. And the person who's seeing patients would be going into a facility most of the time. But what my days usually look like, my PI is very hands-off. So there's no set time. I can come and go whenever I want to, which is really nice for me, but also can be a struggle for people who need that kind of structure. So it's important to keep in mind like what you need to succeed. So yeah, I would usually get up around 8 and then I go into my lab, I check emails, and then I do a lot of like technical work with my hands. So I'll do tissue culture and grow cells in lab, or I'll do experiments. We do sometimes do mouse experiments where we test if drugs work on tumors in mice. That's to make sure the drugs works and is safe before giving it to humans. And then what's actually really nice, I really enjoyed about the PhD is you can be productive, like doing those experiments with your hands, but then you can be listening and doing other things. So like I would always listen to podcasts about all sorts of things. And so it was fun because like I was being productive and making progress in my PhD, but also like having a fun time listening to whatever podcast I was listening to. But yeah, and then of course there's like intermingled some classes, but not as much as in medical school usually. And a PhD is a lot of reading literature and a lot of writing grants and papers and making figures. So it's really like you got to be a jack of all trades to get your PhD and learn how to write well and kind of be an artist, a graphic designer with your figures, and a good communicator to explain your concepts in the paper to other scientists. And yeah, there's a lot of layers to it, but it's actually a lot of fun because it's so much more creative and personally driven than the medical side is, at least at this point.
Okay. And then when you're not in lab or working with patients, what do you like to do in your free time to relax, or if you need to take breaks, or maybe if you're stressed out, or any of those types of things?
Yeah, absolutely. So I already mentioned podcasts. I love podcasts. And actually, I do thoroughly enjoy some good reality TV. I'm a big fan of, Real Housewives. Anything that I feel like I think all day long, the last thing I want to do is come home and think more with a really complicated TV show. So I like that. And then I honestly spend a lot of time with my friends. I'm married, so fortunately, and I say that because it can be very stressful to go through an MD PhD program. So I've been very fortunate to have a very supportive spouse. We actually got married during my PhD process. So of course, it's no requirement at all to have a partner in an MD PhD program. I'm not saying that at all, but it is helpful to have someone who will cook my meals for me and do my laundry if I don't happen to have the time to do it myself. But yeah, really just honestly on my free time, I try to just relax as much as possible and kind of use my brain as little as possible, save that energy for when I'm at work.
Gotcha. That definitely makes sense to just save that energy so that you don't have to think 24/7 come like all the time. But do you also have any study or time management tips for like undergraduates, like looking to go into medical or grad school, things that they should start practicing before they kind of start their program or that kind of thing?
Yeah, absolutely. I think for me personally, because I did take so much time off between undergrad and med school and I had a job that was structured in its time, it really helped me understand that sometimes it's not helpful to work lots and lots of hours, right? Sometimes if you're studying for like 16 hours, maybe only 8 of those hours have been productive. So if you're not being productive, it's important to recognize that and give yourself a break. Sometimes you're too tired to really comprehend. So instead of just keep going because of the amount of time, recognize that maybe you should sleep and you'll be better in the morning. You'll have a sharper mind and be more relaxed. And I know you guys probably hear this all the time, like wellness, and I don't eat particularly well and I don't exercise a bunch. So maybe I'm not the one to talk about wellness, but I do think it's important to remember like there's a balance. And sometimes when I'll get really overwhelmed with my schoolwork, I just go for a walk outside, and I live in Washington, D.C., and it's nice to be like, oh, look, there's a whole world out here that's not at all related to what I'm working on and all these problems that I think I'm having in my, schooling is very like isolated to me, and they're not as big as I think they are when I'm sitting alone by my computer for days on end. So just keeping perspective and taking breaks. If you need help, talk to someone about it. There's so many people who want to help you out there. You're not alone. So talk to colleagues, talk to professors. And I think the one last thing that I wish I had embraced sooner is that you are in school. And often if you're in undergrad, you're paying to be in school for people to teach you. So if you don't understand something, it might be faster for you just to ask your professor, hey, I don't understand this. Can you explain it to me? Instead of spending God knows how long trying to figure it out on your own, or ask a colleague or someone like that. And especially when it gets to med school, there's so many people around that it's just faster to speak up and get over the fact that you don't know it and the fact that other people will know you don't know it. Because once you ask, and then you will know it and it'll be okay. So I think that, and then in terms of time management, it's so dependent on person to person. And yeah, just find what works for you and stick with it.
Okay, awesome. And then do you have any words of encouragement, once again, for high schoolers, undergrads, or just anybody that's in STEM or people that want to go into STEM or are interested in learning more about it? Like any words of encouragement for them?
Yeah, absolutely. So actually, I am a first generation student, so my parents didn't go to college. And so maybe I overcompensated by going to like the most lengthy educational program ever. But I think there's definitely times where it will be really hard. Getting into med school is really stressful, I'm not gonna lie. And being in med school is also stressful. But it's also a lot of fun. And if you don't get in your first try, if you don't get into a PhD program your first try, just honestly don't give up. There's so many resources out there. And another plug actually is Twitter. I think Twitter is a really great place, maybe not for high schoolers, it might be a little traumatic. Twitter can be a terrible place. But there's a really good medical community and graduate community. So you can follow along people, and everyone's very open to being reached out to. If, say, a lot of people don't know doctors or PhDs, I should say medical doctors or PhDs that they can ask questions to. So don't be afraid to like reach out to people on Twitter or social media and ask for guidance. And don't give up. It'll definitely be hard and there'll be setbacks and it won't go the way that you plan, but I'm really happy I have done and made the decisions to do this program. And I think if people want to do it, they really should.
Thank you. And then thank you so much for joining me today and for being willing to come on and share your experience and advice for other people that might want to go into this. I appreciate it.
Of course. And can I put a memo on the podcast that if anybody has questions about MD PhD programs or PhD programs or MD programs or cancer research, they can feel free to email me.
Yes, absolutely. I will definitely put that in the caption.
Great.
In the last part of this podcast interview, Dr. Fitzgerald mentioned that there are two types of anti-tumor immune cells, which are natural killer cells and T cells, and that when cancer develops, the T cells cannot recognize or clear the cancer cells. On top of that, she added that CAR T cells, or chimeric antigen receptor T cells, have been engineered to recognize specific proteins that are overexpressed on cancer cells. She mentioned that there are many layers to getting a PhD, including graphic design, reading papers, and doing work towards your specific project. Dr. Fitzgerald enjoys listening to podcasts, watching reality TV, and relaxing in her free time. She also mentioned that if you're not being productive during your study time, it's important to take a break to clear your mind. Taking a walk can serve as a way to keep a well-rounded perspective. Lastly, Dr. Fitzgerald mentions that you're in school to learn, so if you can't figure something out, it's important to ask for help. Don't be afraid of not knowing something. Thank you for watching the third episode of the Doc Talk with Liz podcast. Don't forget to like and subscribe for future videos, and please follow our Facebook, Instagram, and Twitter for future updates.